Hello, this video is on Gay-Lussac's law. We're going to state what the law says and then work a problem with it. Alright, Gay-Lussac's law says that if you have a fixed amount of gas at a constant volume, the pressure is proportional to the temperature. Okay, and so if you think about this, it makes sense. So if you heat a gas, what do you think happens if you heat it? If you increase temperature, do you think the pressure would increase or decrease? Okay, so if you think about it, most people know if you heat gases, then you're going to start building up more and more pressure. Okay, and so like I've said in a previous video, this can be dangerous if precautions aren't taken, especially in a laboratory. So if the pressure increases when temperature increases and vice versa. So they have a direct relationship. Okay, and so here you see we have a, if we increase the temperature, then our volume is the same. Okay, it stays at 2. Okay, but if we increase the temperature, then we also increase the pressure. Okay, so the gas particles have more kinetic energy when they are heated. So they start moving faster and faster, and this exerts pressure. So we have an equation for Gay-Lussac's law. It's P1T1 over P2T2. The P and T are for pressure and temperature. The 1s are for the initial conditions, and the 2s are for the final conditions. Okay, and so we're going to work a problem using this law. Okay, you have a 0.50 liter gas. Here, that number is not used. It's just telling you you have that amount of gas and that volume does not change. You have a temperature of 25 degrees C. Okay, and so our T1 is 25 degrees C. For any of our gas law equations, we have to convert to Kelvin. So we add 273. Okay, so we're basically at room temperature here. And our pressure is 1. The temperature is changed to 310 Kelvin. And we want to know, how does that change the pressure? So if you compare your temperatures here, okay, the temperature goes up. Okay, not by a whole lot here, so just by about 12 units. Okay, so we go from 298 to 310. But we do know that if we increase temperature, we increase pressure. So our final pressure should be a little bit more than 1. Okay, so if we plug this in, we have P1 over T1 equals P2 over T2. We're looking for P2, so we have to isolate it by itself. So this is just rearranging the equation. Okay, T2 is 310. I'm going to go ahead and give a 3 sig figs there. P1 is 1 ATM. T1 is 298. Kelvins cancel. We're left with ATM. And we get a slightly higher pressure of 1.04 ATM. All right, I hope this better explains Gay-Lussac's law.